Somehow you got here. Someone may have mentioned us, you may have seen something online, or maybe we showed up in front of you. Either way, if this is your first time seeing Project Moonhat, what you're about to encounter can feel big, maybe even overwhelming. So instead of throwing a presentation at you, I'm going to speak to you directly and explain what we're actually building and why. And one thing up front, this isn't finished. It's a build in motion. Let's start big. The world today is being challenged in a variety of ways. We call them the 6 mega challenges. And I'm not going to break them down here, but each of the systems that support our daily life, infrastructure, food, materials, energy, economics, education, are all under strain. Most responses to strain are what are called first-order solutions. So a first-order solution is real and it is necessary. It addresses what's right in front of us. You feed the hungry child, you save the dolphin, you clear the river. But when you're done, you still have to go back tomorrow and do it again, because the underlying systems haven't changed. So we focus on second-order solutions. And second-order solutions are the systems underneath the systems, the redesign of how things actually work. We're not trying just to feed the child or save the dolphin. We're working on the systems that reshape those realities long-term. Let's put scale around this. Roughly 52 to 68% of the world's population lives on $10 a day or less. About half of the world lives on roughly $6 a day or less. If most of humanity is operating under these conditions, we cannot solve that with isolated fixes. We have to look at the underlying systems, how materials move, how food is produced, how energy is generated, how ideas spread, how education works, how opportunities flow. That's second-order work. What does this look like in practice? The world runs on materials from Earth. We move roughly 100 billion tons of material every year just to sustain modern civilization. That's not stopping. So, for example, we're working on telerobotic and semi-autonomous robotic systems to reshape how material is accessed and produced. We're working on food systems, not incremental change, but systems that can replace up to 6% of our fragile agricultural systems over time. We're working on education because much of today's systems are designed for literally another century. And we're building ways to bring builders together to work on long-term structural change. What you may have noticed is when you're looking through the website is individuals step in at different stages, early, later, quietly, behind the scenes. If you're someone who builds, whether it be capital, systems, infrastructure, science, you'll likely begin to see where you fit in. There's another challenge that doesn't get talked about enough, though. A significant portion of humanity does not believe there's a future worth building towards. Even a conservative estimate suggests that somewhere in the neighborhood of 30% of the individuals of our global population do not believe there's a future in the future. Try running an organization where 30% of the people believe that the organization has no future. You can't build anything. Society can't come from that position either. Part of this work, the work we do, is rebuilding the conditions where people can see a future again. Now here's where people get confused. They hear the moon in our name and assume that it's a space project. It isn't. I'm not a space person. I don't look up. I solve large structural challenges. We use the moon as a forcing function, a piece of the puzzle, not the puzzle. And NASA named us, so we kept the name. What's important to understand is that throughout history, humanity has advanced by moving into new frontiers. That's the way we've done it. Not always because it's romantic, but because it forces new precision and new systems. The moon compresses constraints. Extreme temperatures, no water, no air, radiation, distance, far distance, resource limitations, zero tolerance for inefficiency. At worst case, it's a test case for a future Earth. Just think about it this way. If global temperatures shifted slightly, 1 degree C or 2 degrees Fahrenheit, billions of people face disruption of food, water, and safety. And upwards of 3.5 billion people will be impacted in a way that has not happened in over 6,000 years. So in solving for the moon level constraints, we build better systems here. Robotics, materials, energy, logistics, food, coordination, all wrapped into one, and we've done this before. How do you think we got MRIs and GPS and the advanced materials in our running shoes, the communication systems and the cordless tools we have, or the cordless headsets? These innovations were designed for beyond Earth, but they stay on Earth. We're leveraging the moon to accelerate better systems for life on Earth. And if you're wondering if we're working on the moon too, yes, we already have invested just in the design and scale model development 16,000 hours. In fact, we've been told that we have the most in-depth and detailed plans for the moon of anyone on the planet. But let's take a quick jump. On the surface, the world is dealing with conflict, pressure, instability. We now have more distinctly separate conflicts on Earth than at any point in recorded history. What we're doing is building underneath existing systems new systems that they can operate for centuries to come. Think of it as a new set of rails under the current rails that are operating. Those systems take time. We're on a 40-year trajectory. We end up completing in 2063, and we expect a major inflection from the work that we're working on in 2043, meaning we're going to eventually get there. How old will you be in 20 years? Ask yourself that. What will the world actually look like? That's a question for you. What systems will support life then? Well, that's the horizon we're building for. But to give you a reference of how difficult this has been over time, in 1543, Copernicus proposed that the Earth revolved around the sun. That was radical. It took roughly 300 years for that to be widely accepted. It wasn't until the 1800s. But Galileo and Descartes and Newton, they all had to contribute to this change before it became widely accepted. Structural shifts take time, and we don't have 300 years to stumble forward. Yet we believe we can intentionally build systems that create better outcomes over our 40-year time, because the moon is already a known entity, unlike where Copernicus started. As you explore what we're building, you may see pieces that look disconnected. They aren't. There is a long horizon second-order build designed to improve life on Earth over time. We're not finished. We're building. And if you're someone who builds capital, systems, infrastructure, science, education, and art, design, whatever it may be, you'll likely see where you fit as you look deeper. If this resonates, explore further. You'll begin to see how it connects and where you might fit.